I'm going to try and run through these things. So first is resources, maybe a couple websites that you can look at as far as already existing models, so you wouldn't have to CAD something from scratch. Helpful tips in terms of user interface, some basic sketching and features, and that's kind of where we'll end up is some basic features. And then as you have questions along the way, we can address those. So some websites that are really great for just finding some 3D models are Thingiverse is one. These are more of your toys and things like that, but if you type something specific into Thingiverse, they may have some models of those that you can grab that are either organic in shape or something like that that's more what you're looking for. Another website's called GrabCAD. You need an account on this website, but it has more of these engineering models where, you know, it'll have like intricate parts, gears, engines, all kinds of really advanced stuff, brackets. And if you look down here, sometimes they'll have Solidworks listed. And in that case, you'll get a solid part file. And you can go through the order of operations that they did to make it. You can edit that file. So that's pretty nice too. And the last one I'll show you is McMaster. This is where we pull all of our raw materials and kind of basic tools. They will have CAD files for a lot of these more simple things. Like if I have like a certain screw that I'm looking for, if I needed to make some device that had screws in it and I don't want to CAD a screw from scratch just to see what it's going to look like or if it's going to fit. If you go into here and look at the part, usually they'll have this little CAD icon and you can click that. And then if you scroll down, they'll have a SolidWorks file available and you can save that and it will save it with the McMaster ID number here. And when you open that up, you'll see how they made it, which is pretty cool. Okay, so those are basic, the resources. Now this is sort of user interface. The first thing you see when you open SolidWorks is this screen. You're gonna do Control N or click a new and you'll see this pop up. This is what we're gonna make today. An assembly is a bunch of parts put together in a certain way and you define that. That'll be like the third video. And then a drawing file, which you might use if you're sending a part to a machine shop to fabricate, but most of the time you guys don't have to worry about making those. So part is what we'll choose. Okay, and then within this screen, we've got this part, which is the most important. This is called a feature tree. We've got tabs across the top, and the most often we're going to be using Sketch, which is two-dimensional stuff. Let's see. We're going to use features, and then sometimes we'll use evaluate, but not today. We have 3 planes that we can start sketching on. We've also got a unit system down here. MMGS indicates that we're in millimeters. You can switch that to inches at any time. I'm going to show the chat as well so I can see if anybody has a question. Go ahead and type it in there. Okay, what I'm going to start doing is start a sketch. So I'm going to click on one of these planes and there's icons that pop up. I can also click sketch here and choose one of those planes. Doesn't really matter which one. And these are all my sketch entities or lines or versions of lines or circles or shapes that I can draw. I'm going to do essentially a bunch of lines that are typically connected to each other in like a loop or a contour is what they call it. And then I'm going to make a three-dimensional feature based on those lines. Does anyone have a request on the type of shape that we'll make? Maybe something fun. I think for our Mechie interviews, we usually make a robot cat, so I'll try one of those. All right. Don't judge me on my robot cat. All right, so
Star Wars fighter might be too much to ask, right?
Say again?
A Star Wars fighter might be too much to ask.
Oh, that's a challenge, but
No, don't worry about
it. Okay, so what you'll notice is I selected the entity and my cursor changed to a pencil, which is sketching. There's a little icon under it that's just a line. If I switch to a circle, you see the difference there. There are different versions of a lot of these things, but most often you're going to use the basics one. As I hover over the origin, I get a little yellow box, and that is what's called a relation, which defines how the lines are positioned. It could be how the line connects to a point. It could be how two lines are related to each other, like parallel or perpendicular, or a line coming off of a circle. It can be tangent, things like that, or an arc. So I'm going to click first on the origin. It ties it to the origin. And then I'm going to click vertically above the origin, and you'll see another yellow line pop up. That's tying it vertically above the line, or fixing it to be vertical. If I want to get out of this line tool, I'm going to hit escape. And you'll notice the line is black, which means it's fixed in the vertical position, but my endpoint is actually blue, if you can see that, and that means I can drag it. So when things are blue, that means you can drag them around, and that means that the sketch is not fully defined, or that your degrees of freedom is greater than 0. And you'll see that underdefined here. Okay. I'm going to go ahead, and what's typical is to rough sketch out your entire object and then go back and put dimensions on all of those lines. So let's put some more lines in here. I'm going to click this, which means that yellow icon is tying it to the endpoint of the previous line. A very common mistake is to not click accurately and to leave a little tiny gap between those two lines, which is not good. So I'm going to do that on purpose. What's nice is these tie lines, which show you that it's roughly horizontal to it, to the origin. Click there, and I'll click back to the origin. Okay. And I'm going to hit escape to get out of the tool. So right now, this line is not fully defined. I can drag it around. And if I drag it back to this point, it closes that loop, or what we call a closed contour, and the shape gets filled in, telling me that it's working well. This is one of the later versions of Solidworks that started to do this. Okay, and now I'm going to define some things about these lines. So you can see that this is also fixed horizontally. So I can move this, and I can move this vertical. I can also probably grab this and move it out. So it just depends. To define some dimensions, I'm going to click this Smart Dimension tool. And I'm going to show you the shortcut, which I love to use, and it saves a lot of time, which is to right-click on my mouse and drag it a little bit. So I'm clicking and dragging. Now, if I don't drag all the way to the outside of that, it's not going to do anything. But if I drag it and keep going out, it changes to that tool. So I can do that to make lines or dimension stuff, or if I do it twice, it toggles it off. Right, so I'm going to dimension maybe the length of this line. So click on the line, click over here, and type in the dimension that you want. Now it's in millimeters, so I'm going to do 1 inch, right, 25.4 millimeter. Let's say I want to make an equilateral triangle here. So I can also, instead of clicking on this line, I can click on 2 points, which you may want to do in some situations where you're not dimensioning a line, but instead the distance across your entire part or something like that. So I click the 2 points. I'm going to place it over here. You can also type in different dimensions. If you knew it in inches, then you can type in 1 inch, and it will also work. It's just going to convert it for you. Okay. If I want to, edit this dimension, just double click it. Type in something else. You can do math. You can multiply by 2. So that's kind of cool. You can also base it off of other dimensions. So if I hit equals, and I know I want the ratio to be like half of this one, like always, I can click on it and say multiply by a half. Hit enter again, and now there's an equation here. So if I update this one, it's gonna also update this one, which is pretty nice. Okay, now imagine like I was really happy about my model, I zoomed in and I lost it, right? That's pretty common to do when you're first starting out. So the shortcut you want to use is the F key on the keyboard. and that's going to fit it to your screen. Also, if you click the middle mouse button and rotate, right, and I lost the angle, I'm trying to sketch it, it looks weird, right? You can click this normal to button. Sorry, my mouse is weird. Now, you probably don't have that by default. So if you want to add that to your screen, just click up here. You may have it on help by default. So click down and choose commands. And you can search for any function this way. So you would just type normal to, and then you would drag it from there out here. So if you click it twice, it reverses it. Okay, now we got a basic sketch. I'm going to make it three-dimensional. So you can go directly over to the Features tab, and what you'll notice is these three-dimensional operations are organized into sort of batches. This first batch makes all positive type shapes. This one, this next batch cuts out shapes or does negative operations. This one is sort of rounding off edges and any other like special operations that are not frequently used. Okay, and this is the order of operations that you should do to make a model. You should make all of your positive shapes, then cut all of your negative shapes, then round off your edges. In that order, because it's the most robust way to make your model, meaning that if you go make changes later, it's not going to ruin the features that you've made previously. Okay, so let's just do something simple. Let's extrude this a little bit. You can extrude it a defined amount. So let's do 1 inch. Okay. So you can also drag this. If you want to just eyeball it, you don't know exactly how big, but you want to visualize it. You can click this arrow to make it go the other way. You can also drop this down and do like a mid-plane, which may be common if your model has symmetry and you want to mirror it later. That will put it as, that'll do like, if you see an inch, it'll do 1 inch total. So it'll do ½ inch either way. Okay, click the checkbox to make that happen. And you'll notice a couple things happened right there. One is we got a new feature here, which is called Boss Extrude 1. If I drop this down, it shows you the sketch that I used to make it. I also got a new solid body up here, which I won't address. If I want to go make edits later, I can right click or left click this, and this icon will allow me to go back and edit that sketch. So I click it, and I can go make edits there. Then I have to exit the sketch here. Okay, if I want to go edit the extrude feature, I can right click this one and choose edit feature or edit the sketch. This will allow me to change the distance that it went. So I've made my positive shape. Now I don't have to sketch on one of these planes anymore. I can sketch on any flat surface of this model, which would help if I had like a weird extrude that needed to come out at an angle, say on this plane. So I'm going to sketch on this plane now. So just click on that plane and click sketch. Okay, and then click normal to. And that'll make it really easy to sketch on that plane. Let's do a different shape. Let's do some circles. Okay, and we're going to just click. Okay, let's make 2 circles here. And I need to dimension those circles. So if I hit escape, I can see how they're fixed in space or not fixed in space by dragging them around. So I can define XY position as well as the size. So let's use our shortcut and dimension this circle to be ½ inch. Okay. And let's set a relation now, so we haven't really done that yet. I want to make this circle vertically above this origin. So this origin is in the center of my part. I just know that, but let's hold shift and select both of those points. And now I've got these relations that pop up here, as well as over here on the left side. So if I click vertical, it'll make the relation here, and it'll also tie my circle vertically above that line, so when I drag it, it will not go horizontal. Okay, now I have to define essentially the Y position of that. So let's say, I don't have to go off the origin either, I can go off like this side. Let's say it's 15. Okay, now that circle is black, which means I cannot move it anymore. If I tried, it would stay there. So I can also tie circles to other circles. And maybe I want it at like a weird angle or something, and I don't know how to dimension that. So if I want to do that really quick for Sid, let's dimension this circle from the side. So I'm using my shortcut, right-clicking and dragging until I get this tool. Click on the center point to position that center point off of the top face or top edge. You see the edge is selected in orange. Position my dimension over here. It's common practice, put your dimensions outside of your part. It's easier to see. Type in a value, hit enter. Okay. Then let's hit escape and let's dimension a circle based on another circle. But maybe there's a weird angle that it's related to the circle width, right? So maybe I can't really dimension it straight off of any edge. So I'm going to use a construction line there. That helps me position things exactly how I want. I can get to that in this line tool, which shows this dotted line. I can also click the line tool and choose for construction, which is the same thing. I can also right-click and drag left to activate the line tool and click construction. And that's the fastest way. So if I just do center point to center point, you'll see the dotted line. I can get out of the line tool by double-clicking or hitting escape. And then let's dimension this line. So let's say you see how this dimension tool changes, right? And also the distance changes. So you have to be careful about where you position this so that it's actually the measurement that you wanted. So let's do a vertical distance, 1 inch. And then let's say it's based off of this also 10 millimeters. Okay, now I can see what's left is the size, right? Let's say these two circles are equal to each other. I can choose both. And I can see there's different relations popping up here. So this one would make them both equal size. This one would place them directly over each other, in which case it wouldn't work because I've already positioned the X and Y, so I could not move it. I can only adjust the size. So make them equal size, and now they're both defined. If your model has a lot of symmetry, you can also put in that construction line to act as a symmetry plane. So go off the origin, make a vertical or horizontal line depending on where you need to mirror things, and use the mirror entities here. And choose, I want to mirror this circle and mirror about this line. And then checkbox. So that can help if you had a lot of symmetry in your model and you don't want to like dimension and make a lot of sketches. Okay, now I want to cut holes. So let's go directly to features and use these negative shapes here. Let's cut. And if I rotate my view, I can see where they're being cut. I can choose the distance here. I can also do this interesting function, which is an offset from surface. So this is maybe an advanced function, but kind of shows you the power of these tools. Let's say I want to offset it by 1.5 millimeters. And what that's going to do is give me this little solid layer of 1.5 millimeters, but it's going to cut them at the angle that I showed. So that's kind of cool. Let's just do that. And if I want to really like visualize how those holes are in the inside, I can change my view. So up here, there's a view. And I can show kind of the inside by showing the hidden lines, seeing how they're being cut there. Now I changed my mind and I want to have them go through the whole thing. I can right click, edit the feature, and instead of this, just choose through all. And now they're cut through the whole thing. Okay. A powerful thing to go and like maybe make design changes or edits is to use the rollback feature, which means I can drag this line backward through my feature tree or order of operations, and I can start doing some other functions here. and this will just get pushed to the end. That also helps you if you downloaded a model from GrabCAD and you want to see how it's built in that order of operations, you can use that dragging to sort of step by step go through and watch how they did it. So the reason I said it's the best practices are to go positive, negative, and round off your edges is because if you try to reorder these, it depends which order you do them in. Okay, so now let's round off some edges. What's most common is this fillet tool. So I'll click that. So let's say I want to like fillet these edges. Just click on the edge. Let me go back to the solid. And it's going to show a preview here, full preview, and it's going to show me the 10mm fillet. Maybe let's change it because that looks pretty big. You can just start typing in numbers and see what looks good. Another time saver is when you click this, it's going to have this little pop-up here. And as you hover over them, it's going to show you which edges it's going to fillet. I didn't know this when I first started SolidWorks, and I was ending up like clicking like 20 edges to fillet stuff. Don't do that. Just look at these pop-ups. Another thing you can do, you don't have to click edges. You can click an entire face, and it will fillet everything connected to that face. So that can be useful at times. Okay, so I want to fillet maybe all the circles on either side. Let's do that. Okay, cool. Okay, now I changed my mind. I don't want these holes anymore, but I want to shell out the entire thing and make it like a giant cup, right? A triangle cup, if you will. So I'm going to drag this back before I made those cuts. And let's change the function. I just want to do something else. So let's shell it out. I use this function on the COVID mask that we made for injection molding because in that process you want even thickness of walls in the entire part. So if we click that, I can define the thickness of my wall here. So let's say it's a 0.5 millimeter. And click on the face that's going to be open. So if you were like doing a mug, it'd be the top of the mug. Let's click that. And let's do show preview to see what it looks like. How thin are the walls? Maybe I want thicker than that. Let's do 1.5. And you notice it's not cutting through the bottom here. But if I click the bottom, that's another open face, and it would make a tube. So it can be a powerful tool to make more intricate geometries that way. Okay, so let's check that. Okay, so maybe I want to figure out the distances of these walls at a certain location inside this part. It's hard to like measure, hard to visualize, right? So a nice way to view those features is to do this cross-section. If I click that, it'll essentially chop my part in half using one of these planes, front or side, right? And I can drag this through the part. Sort of see where those slices are. That could be useful if you're designing something for 3D printing and you want to make sure that, you know, the printing slices are going to have like the nice cross-section that it needs or whatever. So I can go, maybe I want to measure something here. So I can click, evaluate, measure, get this. And let's measure from this line or that face to the inside face. And I get these box that pops up. That normal distance is the thickness that I defined. So it's the normal distance between the two planes or the two faces. Okay. We can turn off this cross-section view. And maybe I want to evaluate like how heavy this part is. So in that, I would need the material to be defined. So from this material, I can choose one. I can just right click and say this is made out of, it's made like a 3D printed it, so maybe it's ABS. Right? It's going to change what it looks like. It's going to define a density. And I can go into this mass properties. And it's going to show me this. All right, the density is not defined in this case, or it's very, very small. But it gives me a mass here, it gives me a volume. So if I'm making microneedles and I need a certain mass of microneedles to be deposited, this is the tool I would use to sort of calculate that, or get a rough estimate of how much volume or how much material is going to be in my entire thing. Okay. If I wanted to know like the volume inside this piece, I could just drag this before the shell and look at the mass, and drag it after the shell and look at the mass, and just subtract them, and then I know how much the inside would, or the volume. I can figure out how much volume would be on the inside of that. So we've done a bunch of sketches. Maybe I will just kind of show you some other sketches. Let's remove this one. 1, 2. Okay, let's show you some of these other tools. So if I drop this down, I can do a corner rectangle. I can do 3-point arc. Click onto points to find the radius. I can make a polygon and choose the number of sides here. So I can do, you know, triangle or square or whatever you want. A spline tool. Right? That can get very complicated in terms of how you're dimensioning that. There's so many ways to dimension these things based on this angle, this distance, right? So for most of the things, I'm using 3-point arc to make curves. You can set relations like make it horizontal. This is an inscribed circle, so I can define distances for this. I might do that if I'm like dimensioning something that needs like the head of a screw or the head of a bolt included in there, so I know like the distance of the hexagon. I can set a relation between these two, right? In that case, it moved my square. So then let's set a relation between these 2 points, these two here, but that's also vertical. Set some distances or radius. Define the size. What else can I move, right? So I'm checking that. So there's a quick way that you saw I dimension that sketch to fully define everything. What you'll notice is I have 2 closed contours here, but this one's open. If I wanted to cut some holes, I can choose which ones are being cut. I can even cut a line, which is strange, but it would use a thin feature. So we won't get into that, but I can use one sketch and I can do multiple features based off that sketch, which is useful if I'm cutting things to different depths. So I can cut this like 3 millimeters, do that. There we go. Let me just get rid of these. See that cut 3 millimeters? I can drop this down, go back to that sketch, and do another cut, and just use the triangle. And cut that on a 6. Right. So that'll help you just make less number of sketches. And if you have like blueprints and things like that, just make like one sketch. If it's all in one orientation, just like put a bunch of contours on that, and then you can dimension or do features as you want. Let's do one more part with Revolve. If I have that rotational symmetry in a part, I may want to revolve something. So in this case, I'll do a quick microneedle. Let's do like a microneedle patch. Right? So I'm going to make a cross section of a single microneedle. It's 1 millimeter tall, and it's 300 micron diameter, which would be 0.3 divided by a half here, divided by 2, sorry. And I'm going to revolve that, which is a feature. And I get to choose the axis of revolution, which will be this one. I can make it go all the way around, but I don't have to. I can do like a half of a needle if I wanted to. And now I want to make, let's say that's the center of my patch. I need to make the base of the patch underneath it. So I'm going to sketch on the flat surface on the bottom. And I'm going to define a dimension of the patch. Maybe it's a rectangle. And this rectangle is a centimeter. So that's going to be 10 by 10. If I want to make it always square, I can just equal this dimension. Enter, enter. Okay. Now I've got a sketch. I'm going to extrude that. Maybe it's a 2 millimeter base. Okay. Maybe I want to, make a lot of microneedles, right? So one other powerful tool to do that is called a fill pattern. You can search for that because it's not available by default. Choose the area that you wanted to populate. Choose a direction that you wanted to go along. And choose the features that you want to copy, which is going to be this thing. Amazing. I can choose distances between them, 0.5 millimeter, 0.5 millimeter. I can choose from many different patterns. So if I want them to be oriented in circles or whatever, I can see how many microneedles are on my patch here. Right. Let's do a square array, and it's going to be 10 by 10. Maybe I can do that. Instances per side. I don't know. Let's just estimate here. All right. Let's do 90 degrees. 1, 2, 3, 4, 5, 6, 7. 5. Okay, let's say that's close enough. And what else? This is a perimeter to define the edge that I don't want the needles to touch. And let's say that's 1 millimeter. Right, so it's going to push them toward the middle. Okay, let's say that's good. And I want to fill at the edges now. And I'm going to use that little pop-up that I told you before to click all 4 edges and make it 1 millimeter or 2 millimeter. Round it off. Okay, now I want to say, like, how much volume do I have in these needles, right? Well, it's going to be hard to kind of click all of them. I don't want to do that. So a cool tool is just showing you convert entities now. So by making a sketch here, clicking on this face, I selected the face and the edges are all light blue, right? When I convert entities, it's gonna take all the edges from whatever faces I selected or any edges that I select and project it onto this current sketch plane, which may sound a little bit strange, which means like I can select the circle from this side and project it onto this face. I don't know why I would need to do that, but I can show you basically how it works. So convert this circle and click. And you see how it took that circle and projected it onto this current plane. Maybe I would want to use that because I need to make sure that whatever feature I have aligns properly with something on the opposite side of my part. So let's delete that. What I want to do is cut out this entire face up to the surface of the needles. So I'm going to convert this entire face. So I've made the edge here and use my cut to go up to the needle. And maybe that distance is going to change later. So I'm going to define it by a vertex. And then I can click on this edge. I guess not, I don't know. Let's just do 2 millimeter. Okay. Now it's giving me this bodies to keep pop-up, which most of the time you don't have to be concerned with, but the reason it's popping up is because each of these needles is not connected to each other. So it's asking me, is that okay? I want to say yes. And now I have the needles isolated, and I'm going to go evaluate their mass or their volume. And that's going to tell me the volume of my whole patch in terms of the needles. So that's one of many types of functions that you could do to do an evaluation of your model. If anybody has any questions up to now, feel free to type it in the chat or just unmute yourself and you can ask me anything specific.
Adam, sorry, I missed the last part of that. How did you calculate the volume of the needles?
I basically cut off this base entirely with this cut extrude. Left me just the needles, and then I did an evaluate of mass properties, and it told me some metrics based on that. So the volume is not going to depend on the material, so I don't need the material defined. But if I wanted the mass itself, then I would define the material that has a density, and it would tell me.
Okay. Could you suppress those other layers instead so that you wouldn't have to get rid of them? Like if, say you just wanted to measure the volume of the needle, but you wanted to keep that other part that you had made. Is there a way to do that? So
the main issue is that I used the area in this fill pattern to make, I used the area of this patch to make the fill pattern. And so if I took away this base, the fill pattern would fail. So if I suppress that, you see that the fill pattern is sort of using some reference from a previous feature. In that case, that's why it won't work in this case. So you always have to think about the later features referencing earlier features. And if I change something later, maybe something else is going to fail earlier. A lot of the time that happens when you make a fillet, and the fillet is, it's okay when you made it, but you change some dimension and now the fillet interferes with something else and then it fails. That's why you usually wait till the end to make all those fillets. So, on this place. But yeah. Okay. Let's see if there's anything I missed.
You can also turn on the tree function to show which features are referencing which parent features as well.
Where is that?
Let's see. I'd have to look at it again.
Okay.
But it's basically like if you select a feature.
Yeah, sometimes it'll show you arrows.
Yeah, I forget how to turn the option on, but the option's there.
Yeah. So
if you, oh, go ahead.
Mm-hmm.
I was going to say, if you right click on a feature, you can do the parent daughter tree for the individual feature.
That was one thing that I didn't reference. So not that specifically, but if I want to go make edits and I don't remember like which one it was, if I click it, it'll be highlighted over here, right? And then I can also right click directly on that feature to go edit. So feel free to like right click on the feature that you want to edit, and that's a faster way to do it. I think I can show you basically how to import like the model here, what it looks like. Well, I guess not. Let's try. There we go. So that's a part imported from McMaster. If I drag it back, you'll see that it started with this. we use this helix that we generated to cut threads into that screw. We extruded a cap. We cut the hole. We did a revolve, a cut here. That's pretty much it. So if I want to go modify this part, I could go into any of these things and say modify what the helix did. So maybe it's a different pitch. It's 1/24. And then it looks funky, but